Hi everyone. This screencast is going to be a quick introduction to the first mandatory practical for the year. Now, a little bit of a navigation first of all. If you go to our class page here, grade 11 physics, then there'll be a set of tiles, unit number 1, and our first topic, the thermal physics, heating processes. Now, this is where you'll find resources, presentations, etc. And our first practical is this one here on boiling ice. So you've got a Word document there that we'll start talking about now. So the setup for this is that we have a small beaker and we have put some ice and some water into the beaker. We have a thermometer on the stand here, which is in the ice. There's also a stirring rod, which isn't shown. And we heat this, there's a Bunsen there, there's a tripod and a gauze mat. So the idea is, of course, that as the heat from the Bunsen is absorbed, then the ice will change phase from solid to liquid. And while there is a mixture of both solid ice and liquid water in the beaker, that phase change, the heat is going, in theory, the heat is going into changing the phase from the solid to the liquid, not into raising the temperature. And the idea then is that as long as we use the stirring rod to keep the mixture fairly uniform, we don't want to get hot spots and cold spots, then the temperature during the phase change should remain fairly constant, close to zero. And then once it's completely liquid, the heat from the Bunsen flame will start raising the temperature of the water. It'll all be liquid water by that stage, and we should see hopefully a nice smooth increase in temperature. Once we reach 100, that's when we're going to see another phase change. So we'll have vapor starting to be formed and escaping away. And while that phase change is occurring, again, the temperature remains steady at 100 at the boiling temperature. So that's the procedure. We have a data table here, and we're going to record every 60 seconds. Now, let's have a bit of a look at what the setup looked like. So if everything's working, you should be seeing a photograph there. So this is the apparatus setup. We can see the stirring rod over here. Bunsen isn't turned on yet. Gauze mat in place. Thermometer. No ice or water in there yet, so we hadn't quite started yet. So let's move on. Now we've got the ice and the water in there. There's the stirring rod. We haven't turned the Bunsen on yet. I don't think we'd turned the Bunsen on yet. So lovely there at 0. Now let's just see if I can, can't zoom in. Maybe if I go to full screen, I can zoom up a bit on that one. Here we go. So let's just zoom up a bit on that temperature scale. So the longer line there is 0. Then moving upwards, by the time we get to this one, we're at 10 degrees. Each of these steps is 1 degree centigrade. Now, down the bottom here, even though they don't have a negative sign, clearly this is temperatures below 0. This is negative 10. So you can see the little red liquid inside there is pretty much exactly touching 0, as we would expect when the ice and water are present together, solid and liquid. Now, the best estimate of that temperature would be 0 degrees. The smallest division between two steps is a single degree, so your uncertainty should be half of that, should be 0.5 degrees. So we'll talk more about recording that in a minute. That's at the start. Now, we've lit the Bunsen by this stage, so the Bunsen is on the heating flame. You can see the blue flame there. There's a bit of a draft in the room, so the Bunsen flame wasn't going directly upwards. We've got here, you can see the thermometer up there, still lots of ice in there, and it's pretty hard to see from this perspective. If I go and have a close look. Now, it probably looks like we're a little bit below 0 there. Again, let's see if I can go any closer without pixelating too much. Now, I'm not 100% sure that when I took this photograph, I was exactly horizontally in line with the thermometer. So I could well be suffering a little bit of parallax error on this reading for this photograph. Even so, we would make our best estimate of that reading, and we would have to decide, is the level there closer to the zero, closer to halfway, or closer to the mark below? So in my opinion, it's closer to the zero. There's a teeny gap. We're not going to start estimating negative zero point 0.1 of a degree when our uncertainty is plus or minus zero point 0.5 of a degree. So if the uncertainty is plus or minus zero point 0.5, as a rough rule of thumb, you'll pretty much be looking at measurements ending in zeros or ending in 0.5s. Right. So that's that one where the experiment was underway. Here we can see the reading is slightly above. So by that stage, I'm going to guess that our ice had completely melted and the heat was starting to transfer in. I think there's one more. There it is. By this stage, our ice is definitely all gone. And zoom up a little bit. You might like to have a practice at reading that reading there, remembering that's 20, 25, going up in steps of one. You'd have to decide, is that closer to 29, closer to 30, or closer to the midpoint? Well, it's pretty close to 30.0, isn't it? 30.0 plus minus 0.5. So that's that. Now, last thing is how we were measuring the times. The procedure said to measure the temperature every 60 seconds. So literally we just looked at the seconds ticking over here on the stopwatch, and now I had some help. So when the stopwatch ticked over to 00, I actually counted up as the stopwatch was going. I'd say 58, 59 now, and then my assistant, Mr. Barkey, he was looking at the thermometer and reacting to the sound of my voice and then reading the temperature, which we wrote down. So there would be, of course, a little bit of reaction time going on there with how long it took me to respond by saying now and how long it took Mr. Barkey to respond when he read the thermometer. So that's pretty much what was going on. Your data table here will look a bit like this. And then there's some questions down here for you to analyze. So I know you're on remote learning, you're not going to be able to actually do this, so the best we can do is share with you some results. So here they are. These are the results of our experiment. Time, so this is the best estimate for time going upwards. This is our uncertainty in time. We're probably being a little bit pessimistic there because realistically, did it take a second for me to respond to the stopwatch ticking over and then a second for Mr. Barkey to make the reading? But I think we'll find that the uncertainties in time are comparatively very small. So that's that one. Now here is our ice temperature. So it's really the mixture of ice and water together. These are our best estimates. Remember what we were saying about the numbers ending in decimal 0 or decimal 5? Because we can make those readings to the nearest half of the smallest. This is our uncertainty, 0.5 of a degree. So those are the times with uncertainties. Those are the temperatures that were recorded with uncertainties. If you need to pause to copy them down, that's fine, of course. Now, you may need to put a few more lines into the table. Identify steps you can take to ensure your measurements are as good as possible. Well, hopefully you'll pick up some ideas from the photographs I took and the descriptions I made. And then finally, your job after copying that data down is to answer these questions here in the analysis, then to construct the XY scatter graph according to these instructions. We will have horizontal and vertical error bars on the graph. Now it may be that the error bars are very small compared to the size of the steps on your graph. So sometimes the error bars are so small they're very, very difficult to draw. Other times the error bars are quite large. We plot the average X and the average Y point on your graph. That's an important idea for when we're doing a line of best fit. We'll have more details about lines of best fit in a separate screencast, and then we construct our line of best fit, making sure it goes through that average point and goes as close as possible to the other data points. Then we calculate the gradient using the good old rise over run. We identify the units for the gradient, which we'll talk about more during our meeting, our online meeting. And then we have a little question here to comment about that. So that's a brief overview of your first mandatory practical. Thanks for watching. See you next time.